So, when we build an AI, what are we really trying to do? Are we just making a machine that can spit back exactly what we've shown it? Or is the goal something bigger, something smarter? You can boil it all down to a pretty simple question. What's the real difference between a truly intelligent AI and a parrot that just mimics sounds? That question right there is the entire heart of machine learning. And the answer is all about memorization versus generalization. See, a parrot memorizes. It can repeat a phrase perfectly, sure, but it has no idea what it means. It can't come up with a new thought. Generalization, though, that's the real magic. That's the ability to see something totally new, something it's never encountered before, and still make a solid, reliable prediction. That's not just repeating, that's actual learning. But getting to that real learning, well, it's not always a straight path. Just like a student getting ready for a big exam, an AI can fall into two major traps. You can think of them as two really bad study habits, either cramming every single possible detail or just slacking off and not really studying at all. Okay, first up, let's talk about the crammer. In the world of machine learning, we call this overfitting. This is what happens when the model gets way too obsessed with its training data. It doesn't just learn the big ideas, it memorizes every little quirk, every random blip, every piece of what we call noise. It's like it's memorized the textbook so perfectly, it even memorized the typos and coffee stains. But then it completely bombs the exam because the questions are worded slightly differently. And you can spot this happening a mile away. The model's accuracy on the stuff it's already seen, the training data, just keeps going up and up, but the second you show it something new, its accuracy just plummets. You'll often see this on a graph, two lines moving in completely opposite directions. And that is a huge red flag that your model has been cramming, not learning. And on the complete other end of the spectrum, you've got the slacker. We call this underfitting. This happens when your model is just too simple or too lazy to grasp the actual patterns in the data. It's like the student who just skimmed the chapter headings and called it a day. It just didn't put in the effort to learn anything meaningful. So with underfitting, the model is just bad everywhere. It has high error on the data it trained on, and it has high error on new data it's never seen. It's not learning much of anything because it's just not complex enough for the task at hand. So if we want to avoid both the obsessive crammer and the lazy slacker, how do we guide our AI to become that perfect A student? Well, it turns out we have a whole set of knobs and levers we can turn to control the learning process and find that perfect sweet spot right in the middle. And these controls come in two main flavors. First, you've got parameters. These are the things the model learns all by itself, directly from the data. But then you have hyperparameters. Think of these as the study rules that we, the humans, set for the model before it even starts training. For instance, we might set a rule like, hey, don't let your decision tree get any deeper than 10 levels. That's us basically telling the model, don't overthink it and get lost in the weeds. Okay, so setting those study rules is absolutely crucial. And it all comes down to having a really solid, foolproof study plan. A plan that is built around the single most important, unbreakable rule in all of machine learning. Which brings us to the million-dollar question. How do we actually know if our model can generalize? I mean, how can we be sure it's ready for the real world before we set it loose? We can't just take its word for it based on how well it did on the stuff it's already studied. That's not a real test. And here it is, the cardinal rule. Say it with me, never, ever touch your test data. You have to set aside a chunk of your data to be the final exam, and you cannot, under any circumstances, let the model even peek at it while it's studying. Because if you do, you're not testing what it learned, you're just testing if it memorized the answers. So, to force ourselves to follow that rule, we use a very disciplined strategy. We don't just split our data into a study pile and a test pile. No, we split it into 3 distinct sets, and each one has a very specific job. A typical split might look something like this. You see the biggest chunk, maybe 70%, goes to the training set. That makes sense, right? You want the model to have plenty of material to learn from. Then we set aside smaller chunks for tuning and for that all-important final exam. The exact numbers can vary, but the purpose of each set is what really matters. And if we go back to our student analogy, it all clicks into place perfectly. The training set, that's the textbook. It's the core material for learning. The development set is like a stack of practice exams. We use it to try out different study strategies and see which ones work best. And the test set, that's the final exam. It stays in a sealed envelope completely unseen until the very end, when we use it one time to get our final honest grade. So the actual process is super methodical. Step 1, you split your data and you lock that test set in a vault. Then you start experimenting. You try a bunch of different study strategies, your hyperparameters, and for each one, you train a brand new model on the textbook data. Then you see how each of those models does on the practice exam, the development set. You pick the one that got the highest score, and only then you take that single best model and let it take the final exam. And that final score, the one you get from a test set, that's everything. It is our best, most honest estimate of how well our AI is actually going to perform out there in the real world on data it has never seen before. This whole discipline process is what gives us the confidence that we've actually built something that has learned, not just memorized. All right, let's bring it all home. What are the big takeaways? First, generalization is the goal, not memorization. We always have to be on the lookout for the two big pitfalls: overfitting, the crammer who just memorizes noise, and underfitting, the slacker who learns nothing. And the key to finding that perfect balance is that disciplined, train, dev, and test split, all built around that one cardinal rule: never, ever, ever touch your test data. So I'll leave you with this thought. Now that you know the proper way an AI is supposed to learn, start looking at the AI you use every day. Can you spot the difference between one that seems to truly understand things and one that might just be a really, really good parrot? Thanks for joining me.